All right, everyone, welcome to our DevOps office hours. It's September 7th, 2022. My name's Eric Osterman, and I'll be leading the conversation. I'm the founder and CEO of Cloud Posse. Forgot about that for a second there. We're a DevOps accelerator, and that means that we help companies own their infrastructure in record time by building it with your team and showing them the ropes. So if that sounds interesting, head over to cloudposse.com/quiz to get started. For those of you new to the call, the format today is very informal. My goal is to get your questions answered. So if you want to jump in and participate, just make sure to unmute yourself at any time. If you're tuning in from our podcast or YouTube channel, you can register for these live and interactive sessions by going to cloudposse.com/officehours. Again, that's cloudposse.com/officehours. We host these calls every week. Our call today is recorded. We'll automatically post a recording of this session to our YouTube channel. So if you enjoy the content and want to support what we do over here, hit those like and subscribe buttons. It helps us out a great bit. So with that said, got some announcements here. First and foremost is, if you haven't yet registered for HashiConf and you want to go, please do. I just booked my tickets today, and I'll be there start of October there, 4 through 6. I haven't yet looked at what all the talks are going to be. I'm mostly interested in just meeting the community and everyone else, adjacent to that. If you are going to be there, please reach out to me on Slack, message me. It'd be great to meet up with you there too. So, looks like there was a copy pasta mistake there. NixOS, Atmos. There we go. So we just got our pull request adding Atmos to NixOS approved and merged. So you can access Atmos now from NixOS if you're using that, like for local development, for example, as it's gotten more and more popular. Also, Mitchell Hashimoto has been a big proponent of using NixOS for local development, and it sounds like he does most of his development that way too. So if you haven't checked it out, I hear only good things about it. Personally, I haven't started using it yet. I know members of our team are starting to dabble with it. Any questions on this before we move on? And a kind of early or premature announcement here is that we just cut the first release of Atmos, adding a generator for Atlantis. So if you're using Atlantis today for Terraform, you're familiar with the project Run Atlantis. Run Atlantis kind of invented what GitOps is for Terraform. Before, there were a lot of other commercial vendors like Terraform Cloud, Spacelift, M0, Scalar, and so forth. And Atlantis has taken on a new life almost, and a lot more investment is going into the platform as an open source platform. So what we recently just did was implement support for Atlantis natively in Atmos. So if you're regular on our office hours, you hear us talk a lot about Atmos. Atmos is the tool that we created. It's like a workflow automation tool with a native workflow support for Terraform, but also supports adding workflows for any other tool you use, and using the Atmos complex, powerful inheritance model for YAML configurations to simplify, streamline, and dry up your configurations. So Atmos, because it's YAML, well, guess what? You can just transform YAML from one format to another. So what we did was we had a generator in Atmos now, transform the stack configuration to an Atlantis config file format. Let's see here if we have an example here. So here's an example of what the Atmos configuration would be. So you add a snippet of YAML to your Atmos config, specifying you want an Atlantis integration, where you want that file to be generated, specify the format of your template, your Atmos configuration, and then it will go ahead and generate your Atmos YAML file from your Atmos configurations. This is akin to other tools that have existed too. So there's like a Terragrant Atlantis generator. by Transcend. So if you're a TerraGrunt user and using Atlantis, you might be using this tool. And this is nice because it'll rip through your your TerraGrunt HCL files and figure out what your Atlantis config should look like. That's what this is doing. However, because, hey, we own the Atmos tool, we can do what we want to it. We just built in native support for how it works within Atmos. So to use that, you would just run a simple command like this: Atmos Atlantis generate repo config. You specify the template you want to use and for the project and so forth. We also did another thing with this release. So one of our concerns with customers using TerraGrunt or tools like TerraGrunt is you're creating a Terraform module ecosystem that is tightly vendored into the TerraGrunt tool, and breaking glass from that, if you wanted to switch or use other tools that weren't built with TerraGrunt in mind, is more difficult. So when we built Atmos, we built it from the ground up to work with vanilla Terraform, not requiring injecting any HCL files that were proprietary to the TerraGrunt tool, for example, or the Atmos tool. And we changed the concern to just generating config files, just generating var files for your projects. So that means that if you ever wanted to stop using Atmos, all you need to do is generate those var files, and you can just use Terraform the way you used to 5 years ago. 10 years ago. So with this, we added this command, Atmos Terraform generate var files. This will generate those var files for you. This gets interesting if you're using it together with Atlantis, because Atlantis is a GitOps driven workflow, right? And it looks at the files modified in that commit. So if you use, for example, GitHub Actions together with Atmos, then you can generate those var files and commit them as part of your pull request. That way it makes it very easy for Atlantis to understand the scope of changes of your pull request on the configuration. Now, I realize kind of in saying that, if you haven't been working with Atmos, you wouldn't understand why that's an important thing. And it's probably going into the weeds right now to talk about that. But as soon as we have the page up on atmos.tools, Andre's going to be opening up the pull request, adding the documentation for how to use it. When we have that, I'll bring this up again and go over kind of some of the underpinning technology changes you might need to make. All right. Any questions on our Atlantis support for Atmos?
Are you folks looking to use Atmos? Or are you looking to use Atmos? Are you looking to use Atlantis?
Sorry, I didn't even get that until you corrected it, and I understood. Yeah, so I don't think right now we're immediately looking to start using Atlantis predominantly as our go-to option. We are doing this for two reasons. One is we acknowledge there's smaller companies out there who can't afford the Rolls Royce, Spacelift and Terraform Cloud and so forth, these expensive solutions, but they can justify something like Atlantis. We have been in conversations previously where customers have asked us, why don't we just use Atlantis? And I said, well, guess what? You can. And this is proof. What I like about this is proof. Yes, you can use it, but now you get to compare and contrast for yourself, like those differences. And I think one of the biggest shortcomings of Atlantis is the lack yet of any centralized dashboard to understand at a glance the health of your infrastructure as code. Pull requests are great, but what do you do about like drift detection, and how do you surface that, and how do you visualize the overall status of all of your Terraform stacks that are deployed? Are they passing? Are they not passing? When did they stop passing? All of that. So I welcome when that is possible as well. I think what's interesting about this too is just realize how powerful this is, because while we don't currently support Terraform Cloud from a maintenance perspective, 2 years ago we validated that it was possible, but you can't use this module right now. It's not been updated and it probably doesn't work. It was updated 2 years ago and nobody's using it. But my point here is, because we have this generic YAML configuration that we've devised, we can now translate that for multiple systems. So we have a Terraform module that can Terraform Spacelift. We have a Terraform module that's out of date that could Terraform Cloud, but it needs some tender loving care. And now we showed that we can have Atmos generate those YAML configs for Atlantis. So this is buying you a lot of versatility. By just choosing this framework that we've constructed, you can mix and match the different tools available based on your requirements or financial situation. Imagine a generator for GitHub Actions, or other platforms like that.
If only GitHub Actions had that dashboard as well. It has the same problem as Atlantis.
Tell me about it.
Yeah. Interesting.
But there should be a natively hosted dashboard by GitHub for that. I can only imagine it's in the works. There is what you've been on Office Hours regularly. We've dropped a couple examples. There's recently a pretty nice one with a bootstrappy UI that shows you all of your builds across all your repos in one dashboard that you can filter. But that's, you still have to host that. You still gotta protect that, and it's only going to get deprecated. So
yeah, I hear you.
Yeah. So let's see here.
Just want to say that this is cool. I'm not going to use Atlantis either, but I'm excited for you guys to be adding support for it, only for the perspective that you're investing in Atmos for things that Cloud Posse isn't even using. And that seems to me a sign to me that you're really putting the effort into it, which I think is awesome. And I've seen that, I'm very much following the project. I'm using it a lot, but it usually is stuff that benefits the Cloud Posse thought process and stream of stuff. And the fact that you're adding support for something that you're not actually getting inherent value from, I think that's cool. So kudos to you folks.
I appreciate that, Matt. It means a lot.
I meant to say it before when we were mentioning dashboards, but I've looked several times now and kicked the tires a bit on the GitHub, the Datadog CICD integration, and it actually does a pretty good job of visualizing your GitHub actions and things that get done around them. So it's not perfect, but at least it is an out of the box thing that you don't have to host. If you're already using Datadog, it's just like an add-on, and you point it at GitHub and it shows you all of your projects, all of your runs, all of the status of that with greens and reds and all those kinds of things that you would expect. And you can in the Datadog ecosystem, you can create events and alerts and all of the things that you would want around that pretty easily. So it's at least a semi-viable solution, albeit definitely not perfect, but at least it gets you part of the way there.
Yeah,
that's great to know.
Which is the conundrum, right? Because I want that dashboard in GitHub, but then it's inevitably not going to support all those. Well, now how do I see the trend report or the history? And that's what you get in Datadog. So I think it's a pretty good viable alternative. That'd be cool, Matt, if you want to do a demo sometime of that.
Yeah, I could do that. We could do that on maybe either next week or the week after his call.
Okay, cool. Next announcement, just a minor one. This is exciting in a small way, a little bit for me. So AWS Control Tower has announced APIs for managing your guardrails. That means that inevitably Terraform support will fast follow that. Now, Control Tower has been pretty limited in any kind of API since inception. So while this isn't the one that we really want to see, like programmatic account creation through APIs for Control Tower, because account factories for Terraform is not the answer in my mind. I'm not jazzed about it. But I do think that this is a pretty cool step in that right direction. Anything to add to that? Cool. This next announcement is exciting for anyone who's made the jump to Karpenter for their autoscaler for EKS. So why this is so significant is now it can continuously consolidate your workloads on your EC2 instances, because the inevitable situation for anybody using Kubernetes is you end up getting a lot of these nodes that are deployed with these workloads that can't be rescheduled, and then you are stuck with low efficiency or low utilization on your clusters. So this helps kind of with the bin packing by consolidating the workloads onto fewer nodes. And the other thing is, for those who aren't familiar with Karpenter, what makes Karpenter so special as an autoscaler for Kubernetes is that it finally moves away from leaning on autoscale groups for your nodes. So Karpenter becomes the autoscale controller itself, managing the nodes outside of an autoscale group context, so it can have a heterogeneous collection of nodes. So the Karpenter controller knows exactly how much memory you need, how much CPU you need based on requests and so forth, so it can spin up the most economical combination of EC2 instances to satisfy that workload. So you take that combined with this workload consolidation, and you can run a pretty lean, mean Kubernetes machine. Obviously, this just was announced. We haven't tried it out yet. Seems cool. Anything to add to that?
I tried it. It's awesome.
Oh, really? Cool.
It's solving one of the like before this, a lot of people couldn't adopt Karpenter because Karpenter wouldn't scale down. So for folks doing cluster autoscaler, this is kind of equivalent to the min utilization threshold in cluster autoscaler. So hey, if a node is like only 10% utilized, we only have one pod on it, get rid of it. If you can schedule that on another node and respecting pod disruption budgets. Karpenter couldn't do that. It wasn't necessarily a problem if you like only used nodes for a single deployment that was scaling up and down, and you could cleanly get rid of underutilized nodes. But with this, I believe Karpenter is kind of at parity with cluster autoscaler, and the reasons to use cluster autoscaler on AWS are fewer and fewer.
Yep. Oh, that's really good additional context. I wasn't thinking of that. Thanks.
I got a question, I guess. I'm a GCP guy over here. Sorry, I'm kind of new to this chat. Yeah, so how does this compare to something like Google Cloud's Autopilot? This is something that I haven't tested with your infrastructure as of yet. I wanted to see how it would perform just migrating your stuff in there, see what it would do. But it kind of seems like there's similar. I mean, Autopilot does a lot more than just autoscaling.
Yeah, it does your upgrades as well, right?
Correct. Yes.
Yeah. Well, let's just say, like, what was the company that invented Kubernetes?
Right.
Yeah. Yeah. So they're a little bit farther ahead in streamlining, I think, Kubernetes adoption, making it easier. I do have some envy over the ease of use of using Kubernetes in GCP. Anybody who's started there and then moving over to AWS is like, why is this so difficult? So with that said, I don't know if it's a fair comparison. I guess this brings to parity the auto-scaling, closer to parity to some of the auto-scaling capabilities you would get out of the box with Autopilot.
Gotcha.
Just on that, one thing that I became aware of fairly recently, we were looking at upgrading some very, very old clusters, and like 1.19, 1.20 version of Kubernetes. And if you look at the new support that comes in with Kubernetes 1.22, 23 onwards, you just need to make sure that your workloads are also supported with those Kubernetes enhancements. And we've actually ran into a scenario where some of our workloads were incompatible with some of the Kubernetes enhancements. So we had to go and revisit some of our actual Kubernetes deployment. So just something to keep in mind when you're looking at these tools as well, that, yeah, it's all nice that you get your pod updates and your Kubernetes upgrades out of the box, but it might not be compatible with your actual workloads.
Yeah, that's a good point. And so that's more in context of automatic upgrades and why
Yes.
those are not necessarily the desirable. There's a tool by Fairwinds called Pluto, which is helpful for understanding those API deprecations and compatibility with various versions of Kubernetes. So before you attempt any of those upgrades, this is a great tool to run.
Yep.
It's also
all
a
this is
really
good
good
advice.
reason. Also, a really good reason you want to have non-prod clusters that have parity as close to prod clusters. So when you do the auto upgrades there, and then you break things there and figure it out first.
Yeah.
Yeah, it's better than 17 prod clusters, that one of which has their maintenance period before your staging does.
Yeah.
Yeah.
You company.
Yeah. Looks like you identified an easy win.
Yeah, so I'm trying to replicate the stuff we have in GCP in AWS. That was my first task, which is obviously easy, right? So I mean, that's kind of why I joined this group. But that's why I asked that question to begin with. Yeah.
Cool. Are you
Yeah.
using Terraform
So-
or are you using other tools?
Using Terraform, not to the best, like none of the stuff that you guys are doing here is really being used at all. It was somebody used it once because they needed to make changes to infrastructure, and then that got replicated as many times as we needed, and now it's 100% unmaintainable. So
Yeah, that's.
I'm trying to go back and
Yeah. So shameless plug, but if you're going to deploy EKS with Terraform, really take a good look at our open source like EKS module. It gets around a lot of the bugs and things that you'll probably run into, and is really feature rich and has a lot of feature flags and bells and whistles and knobs you can turn to do what you want to do. So just a plug there, but it's actually very full feature.
You're forgiven, man. You're forgiven.
Yeah.
Yeah.
What I actually ended up doing is, in building out a new environment that we were testing with, I split up the VPC creation and the EKS creation, because in EKS you can also have EKS automatically create the VPCs, but we wanted to have some additional security controls at the VPC layer. So I separated that out so that we actually have Terraform create the VPCs and the subnets with all of the controls, and then just have a very basic EKS deployment inside an existing VPC, which was also very easy to get up and running using a lot of your open source modules.
Yeah, and I would also just in general, not to get too far off on a tangent, but VPC is one of those things that you don't change all that often. So it's really really good practice to have it in its own life cycle, so that you're not planning and maintaining and doing all those things with a VPC in general. So I would always recommend creating your VPC separate from any other thing that you're throwing on top of the VPC, just because you don't want to put it in danger accidentally, but something going wrong on an application or a cluster or whatever playing on top of that. So
it surprises me how often that's the case, though, that you look at how people implement their modules. It's like, here's a Terraform module implements an EKS cluster. Wait, what's all this stuff about a VPC? Why is it creating a dedicated VPC for it? Isn't that a little bit opinionated? Yeah.
I think just one other note on your refactoring, Jonathan. Breaking things out into separate states and separate layers is also easier for like refactoring your infrastructure, because you can get the new one tested in isolation and then turn off the old one, that kind of thing.
Yeah.
Gotcha. Much appreciated, guys. This is quite the undertaking.
I know that was a lot more than you asked for, and we were reading far into that question, but yeah.
Oh, it's good. It's good.
But you know, it's interesting because I didn't make the parallel until you brought this up, and usually I'm always talking about how we organize our infrastructure and what our stack configurations look like and things like that, which is a lot more information. But another question I've seen on Stack Overflow frequently is just, well, how should I break my infrastructure apart? Like, what are the logical units? And well, we actually have a great example for that. So under github.com/Cloud Posse, Terraform AWS components, this is how we break down our infrastructure into logical units. For example, we keep the VPCs separate from the cluster we deploy in there, and then we'll have a separate module for ECS or a separate root module for ECS, a separate root module for EKS, a separate root module for Redis. So each one of these has Terraform state. Each one of these has its own life cycle disjoint from the others, and that's how we organize the infrastructure we deploy.
I do like these bite-sized building blocks that you have here, and I read the manifesto, obviously. So
I should
like,
call it that.
and I mean everything like it's ultimately Legos, right? And this is how it should be written. It seems to be like that, but it's difficult to go from looking at random Terraform because it's like it can be anything, right? Completely anything. Into like, what does the architecture actually look like? So.
Yeah, it gets very convoluted quickly if you didn't think about it this way from day one, which is the downside for us going into an engagement. Sometimes it's really hard. We can't really refactor what you have in place. Let's declare bankruptcy on that and start fresh, So
greenfield all the things.
Yeah. Okay, we'll jump into some questions here. Matt Gow, you had a good question here. Has anybody started using ArgoCD-Autopilot at Masterpoint, which is Matt's consulting company? They have been considering it, but their intuition is to go another direction, to bootstrap clusters with Argo. I would still be interested to learn others' experience. So yes and no. So we briefly evaluated it for a large Argo CD project that we started last year at one point. To me, the Argo CD client is akin to a little bit the JX client for Jenkins. It implements opinionated workflow following Argo CD best practices for how to manage Argo CD and setting all that up. And I think it's true in adhering to a lot of these claims. The issue with all of these kinds of things is that then it's CI and CD in my experience is frequently a intimate part of a engineering organization's processes for how they release their software, and there's always one thing that if it could only do this, or if we only worked a little bit different, you'd be frustrated with it. So we the other challenge I have with it is we're like gung-ho about creating full-on GitOps driven workflows. What I mean by that is a declarative configuration that is deployed and managed entirely, say through GitHub Actions or Argo CD or so forth. If I recall correctly, JX is still a command line tool for interacting with Argo CD and for provisioning the setups of that. And I don't believe it was GitOps friendly to do at least all the operations supported by it. So what we do to deploy Argo CD to this day is still using our components. In fact, I think, here's how we deploy the Argo CD deployment repo. Oh, and we're missing though, we have other components, we haven't upstreamed them here. We have another component for how we deploy Argo CD with Terraform as well. And the idea is that use Terraform to bootstrap your operators and then have your operators do the rest of the work. And the reason why we use Terraform to bootstrap the operators is because frequently the operators need IAM roles and policies to function. And you can't do that with pure Kubernetes, or not easily. So why don't we just bite the bullet, do it in Terraform, deploy the operators, and then get that Kubernetes native experience using the CRDs that those operators enable. And Matt, if you want any of the ArgoCD stuff we have for that, yeah, just hit us up and we'll make sure we get that stuff upstreamed.
Yeah, I'd love to see your upstream of it. I've done the Kubernetes, the like Terraform to, Argo handoff before. And I get your point on actually needing, I forget it every single time. IAM roles for service accounts, like you need those. And yeah, Ursa, and some people just have no idea what that is. So then I end up spelling it out, but I forget it then every time. But I get your point. But I think it like my thought process is I just want to get Argo installed and then have Argo manage everything beyond, like that's actually running in the clusters to limit the amount of touching that Terraform, the amount of like hands in the Kubernetes world that Terraform needs.
But I think we're saying the same thing. Yeah,
we are. Because I get the point. I might approach it differently, but I
so I agree with what you're saying. Like the idea is to bootstrap up ArgoCD and so that everything else can happen in Kubernetes from ArgoCD. The nuance to that I'm saying is don't deploy your operators with ArgoCD. So basically your operators are part of your control plane, are part of, not your cross plane, but your control plane, and deploy it that way.
But then beyond,
go on.
I wonder, well, I'll have to see how. I think I might implement it a different way for the client that we're working with right now, and I'll be interested to compare notes at the end, because I feel like I get why you would do that. There's a handoff of creating that Ursa role and what namespace and what you name that service role, and then how you configure that within the operator that actually needs that role. And if you have it all in Terraform, then it's an easy, plug the two together and everything kind of works nicely.
And you have the GitHub repos too, you got to worry about, right? Assuming you're using GitHub, for example. And then you need to set up the branch protections for that. You need to set up the teams and owners, and you got to set up the scaffolding, the files that you're going to need on there.
Well, this is interesting. Do you create a separate repo for each environment or project, or I mean, how often do you create an instance of this component?
So that's a great question. That's another one of our design decisions that we cover when we go over deploying ArgoCD. I don't think that there's a one size fits all size. We've done two or three different patterns. One pattern that we started off with was always doing one deployment repo per instance of ArgoCD. The reason for that was it was just symmetrical. It was easy to manage, and we weren't concerned about understanding all clusters at a glance by looking at a single pane of glass through ArgoCD. It ties in nicely to the philosophy that dev is decoupled from staging, is decoupled from production. We can validate changes in each one of those stages and never affect the other stage. Now, that's not how some people want to use ArgoCD. Some people want to look at ArgoCD and see all of their environments at a glance through one ArgoCD. The ironic thing about ArgoCD is it has some of the gotchas that you had back in the day with Jenkins. Like it's a single master, I believe it's a single master process. Maybe it's multi-thread or whatever, but you can't have HA ArgoCD. And the plugin ecosystem for ArgoCD requires you got to restart ArgoCD. That reminds me of Jenkins quite a lot. And restarting Jenkins disrupts the entire process. All CI and CD just grinds to a halt when you do that. So that means that the more environments that you're deploying through a single ArgoCD, the less you are able to actually make changes to ArgoCD and work with reckless abandonment in dev and staging, for example. And I love that feeling. Like, dude, don't worry about it. You're not going to break anything because you're just in dev or you're just in staging. And that's not the case then if you start crossing those boundaries. Okay, so I've talked about that pattern, one per one deployment repo per ArgoCD. The other combination is a hybrid mode where you have one ArgoCD like per service or per team or some logical way to divide it. What we did was prod and non-prod for one customer. Technically, we did 3. It was prod, non-prod, and preview. So production was still fully isolated, non-production consolidated QA and staging, for example. And then the reason why we had a separate one for preview, well, if you're doing programmatic commits for deployments to Kubernetes to a Git repo, and you have very busy repositories, that history is going to get massive. And I don't want to have to deal with that issue for production deployments or elsewhere. So that's when we decided, well, we need to at least move that over to another history, to another Git repo, so we didn't have to worry about that impacting the history, at a larger scale for production. Like, do you really want to have 1,000 commits a day for 365 days a year, whatever, etc. Now that's over the exaggeration possibly, but okay. So then the question is, and then the third pattern is obviously the mono repo for deployments, and then factor that into everything else I've just said. That's where you have a large blast radius for all environments, a massive Git history over time, slower clones, and it's more dangerous to make any changes to code owners, branch protections, and so forth. And
interesting. I think that I didn't think about the preview environments creating 1,000 commits, but yeah, I've definitely the time that I've done this successfully, it was the mono repo approach. But I think that the amount of repos you have for handling your GitOps manifests or your deployment manifests, whatever you want to call them, doesn't necessarily need to match up to the amount of Argo instances. Like, you can still be single tenant on Argo, which is really, the way to do it. And then, have as many repos as you like, just depending on how, you need to split it up. And, to your point, I think that it depends on how big's the organization. Like, if you're doing preview environments with, 100 developers and they're all committing all the time, then having all your history be in one mono repo of deployment manifests would be kind of defeat one of the big purposes of GitOps, which is you have like a clean history of what happened and when. So I can see the various approaches that you've taken to it. That's interesting.
And we did that one that you suggested there, actually. So in that prod non-prod, it's a multi-tenant deployment repo. So multiple Argo instances are sharing one repo. And then you just separate, you use a folder convention, right? Where it's all separated by cluster or something like that. The other thing we tried to do, as we thought it was an awesome idea, but it does not work in practice, was instead of just doing programmatic commits to main and ArgoCD, for example, we did programmatic pull requests. So you could control deployments. And while elegant, it failed massively in practice because if you didn't merge those in the appropriate order, you could inadvertently roll back. Well, no, worse. You could like if you have pull request 1, 2, and 3, and then you say you merge two, and then after that you merge one. You just roll back everything you did in two.
Okay.
Yeah. So not cool. And then not only that, what really sucks about it is, let's say you do it in order, so you merge one. Well, you just invalidated 2 and 3 because they modified the same line for the same image tag thing. So it was a massive oversight in designing that, trying to use programmatic pull requests that way. So just in case,
See that being problematic.
Yeah.
But what
Okay.
about what about other potential solutions for those problems? If you look at OpenDev, or what is now OpenDev, used to be OpenStack, Zool, which can run all of your, if you subscribe to all of this, you would also then subscribe to having integration testing as part of your deployment. So what Zool would do is it would run your tests on your PR, make sure that your tests pass before actually then publishing your PR, or maybe some. I don't know if you've ever worked with alternative Git systems such as Gerrit, where you actually have a pre-function that can get triggered to run off-system checks and balances to ensure that you end up with that clean lifecycle before actually committing the code.
Yeah, so that's, yeah, so just to clarify for everyone else, because I think that wasn't obvious in my description of what we were doing, is so obviously all the work we were doing was by pull request in like microservice repositories. As part of the CICD of those microservice repositories, they were in turn then doing programmatic commits to a centralized deployment repo for ArgoCD. We tried using pull requests there. What you're suggesting is on those pull requests to that deployment repo, which are not the pull requests that the developer opened up, but pull requests done programmatically, there could have been a separate battery of tests on that pull request, which would have been pretty sweet to do if the other problems hadn't manifested, namely the order. Yeah, namely, we would have had to add more complex GitHub actions that say, hey, if ever a pull request at a lower number, if I am ever I don't know why it's difficult for me right now, but if my pull request number is ever lower than the highest pull request deployed, I should never be a mergeable pull request, right? That there should be a GitHub action to prevent that. And then the other issue was the rebasing. You know, if another pull request merges and affects the same line numbers, my pull request needs to be rebased automatically on top of that to make it mergeable again.
Gotcha.
Yeah. So anyways, that was interesting though. I think we would have probably gotten there if the other things had worked. Any other recommendations for deploying ArgoCD on Kubernetes? Cool. Let's get to Gabriel's question. But
sorry, I was just gonna say,
Vlad's here. Yep, go on, Matt.
I was gonna say just one more thing quickly on that. I forget exactly what the feature is called now, but GitHub introduced that new feature that does the pull request ordering and like queuing and all of that kind of stuff, and that would actually help a lot.
Sets,
I was trying to.
Yeah.
What was it?
Merge sets, I think.
Yes, merge sets. I think you're right, and that would actually help a lot with that problem that you were just describing. I was trying to look it up, and and I couldn't figure it out.
Sounds like something that might help.
Merge queue. Sorry,
the merge queue. Yeah. I couldn't think of what the terminology was, but yeah.
GitLab was ahead of their time.
They've been leading it for a little while, actually. I have some FOMO on that, except for I'll not switch, but I do really. I'm annoyed that GitHub hasn't kept up with GitLab. It used to be GitLab lagged, and now it's always ahead.
Yeah. Sorry, I didn't mean to derail us, but that came to mind.
Oh, just a quick topic here, because I think we can answer it quicker. Has anybody started using Spacelift with CloudFormation already? That's a quiet answer. Yeah, no, I mean, it's just in this case, I don't think this is, I think this is just more reminiscent, or I would say more a result of this being a Terraform centric community, right? That doesn't use a lot of CloudFormation. But I think this is an interesting thing just to touch on for a moment, since we were just talking about ArgoCD, and ArgoCD is like very opinionated on GitOps for Kubernetes and nothing else. And if you want to do something else, make it an operator and deploy a custom resource and still use Kubernetes to deploy it. So for example, if you're using Terraform Cloud and you're using the Terraform enterprise operator for Terraform Cloud on Kubernetes, you could then deploy Terraform with ArgoCD because it's all actually happening by this operator talking to Terraform Cloud. Spacelift, on the other hand, is much like ArgoCD. It's like it's continuous delivery for just any system, and that's why we use it for Terraform. And what we're using it for Terraform is basically anytime it detects a change in the version control or detects a change where what's deployed in Amazon doesn't reconcile with what's deployed in our version control, it proposes a run that we can then confirm and apply. So it's like that model applied to Terraform. Then they extended it to support Kubernetes. So now Spacelift has a native support for Kubernetes. You could actually use Spacelift in place of ArgoCD to some degree. Don't ask, I don't know to the extent like what the pros and cons or the differences would be, other than the naive capabilities of ArgoCD to synchronize what's in version control with your Kubernetes cluster. That is supported by Spacelift now. And they have the same thing now. If you're committing your CloudFormation templates to version control, it can do the same thing. So it's like a very consistent way of doing continuous delivery backed by VCS. Anyone have something to add to that? Wow, I didn't realize there were 22 messages in the Zoom chat. I haven't seen a single one of them. I'll take a look at those in a little bit. All right, next question was one for you, Matt. I'll have you answer it. Let me introduce.
Yeah, I've actually been trying to answer the Zoom questions too, so I think we're.
Oh, okay.
Oh, yeah,
okay.
I think.
Thanks for taking a look at that. So this was a question by Gabrielle. Gabrielle, are you on the phone today? On the line today?
Yes.
Awesome. So let me set up the question for everyone else. So the context is there, and then we will get into answering it. So Gabrielle, you're asking about something that we've mentioned previously on our office hours and how we are managing a federated approach on AWS to IAM and how we use that with tools like Terraform or other infrastructure as code. We use it with GitHub Actions in GitHub OIDC. It works very well as well. Then I want to do, before I get into that, I want to get into just some differences here. So there is AWS SSO, which is a service which is now, Amazon just renamed it to something like Identity Center or something. I forget exactly what it's called. And that is really for how you do roles for humans. It's not really what you're using for your services. And for your services, you're still provisioning IAM roles in your accounts and policies and so forth. You can then connect those IAM roles to allow SSO to assume the AWS SSO to assume those roles, or you can use the SAML-backed approach to trust some identity provider and then assume those roles directly without going through AWS SSO. So there's those two ways. We predominantly actually deploy both. So to be clear, AWS SSO doesn't support multiple identity providers today. You can only have it connected to one. So when Cloud Posse is working with a customer, we always deploy the SAML-backed approach, so we can deploy our own identity provider and manage Cloud Posse users for the duration of that engagement. Then we can just disconnect that connector and we've been fully ejected. So to get into this, we have just done some refactoring on our components and how we manage this. And I think this might be where you are, where your question lies. So what we've decided at Cloud Posse is to congregate around groups, because companies have groups, product teams have groups. It's a native concept of most systems. Opsgenie, Datadog have groups. So IAM is not opinionated in that way, but we decided to become opinionated in that way. So let's start provisioning what we call teams. And we didn't call it groups because we didn't want it to be conflicting with other terms within AWS. Go on,
yeah, just be clear with that. It isn't actually, we don't provision it as IAM groups. We provision them as IAM roles.
Correct.
Yeah.
Yes.
Yeah.
Correct.
Even though you're saying group.
Yes. Well, yeah, exactly. So this concept of groups, but we decided to do it with roles so that we didn't overlap with groups, which are specifically for IAM users. And when you're using AWS SSO or federated IAM, there is no IAM user construct. So therefore, you cannot rely on IAM user groups. And therefore, we built this around this abstract concept we're just calling teams. So teams, think of them like groups, but they're just IAM roles. So with that said, let me pause on my explanation here. Let's just make sure we have everything else answered here. And then I want to let Matt kind of explain a little bit more on what it looks like. So like with IAM in the past, present, I know users, groups, roles, users belong to groups. So I just explained how when we're talking about users now, we're not talking about IAM users because you pretty much don't use IAM users anymore. Groups have permissions enforcing MFA. Well, this now offloads. It's not a requirement of AWS to enforce that. That's a requirement of your identity provider. So if you're using Okta, however Okta manages. Okay, go on, Matt.
Yeah, unless you're using AWS SSO as your IDP,
Okay.
which you can then enforce MFA on it.
Yeah. Yeah, so basically AWS can enforce MFA where it is the IDP, and where you rely on another IDP, well, that's a configuration setting of your IDP.
Yeah, so just on those first 2 points, what I'll say is that construct, it exists usually with what our customers are doing. So usually within their IDP, and just to be clear, so we're talking about IDPs, we mean things like Okta or your Google account or Jump Cloud or Auth0 or any of the places that you might have accounts stored, Active Directory if you're using like ADFS, etc. And generally within that system, you will have users who belong to groups, and then groups who have permissions, and then those permissions inside the IDP determine which roles within AWS you can assume through our whole thing there. So the construct isn't gone from what you were saying, Eric. It's just that it's a shift left of where those groups and users exist. They exist at the source in the IDP.
Shifted left so far, it's not in AWS anymore. It's
Yep.
Yep. No, that's a good point. That's a good clarification. All right. So let's see here. Other accounts have appropriate roles. Users can assume based on the group they're in. Okay. So this now this mapping here happens based on the configuration between your IDP and AWS, basically what rules they can assume. And we're going to show, if we have time here, well, we're almost out of time, more precisely what that could look like in configuration. I guess we're not going to have time today, but we can go into more. Let's go into a more detailed example next week. So let's see here. I want to get to the actual challenge here. So this worked nicely in the CLI. You configure this and this, your AWS credentials and config and
use lead.
Yeah. So yeah, exactly. So how does this work now when with AWS SSO or the federated IAM? Great. So that's a real easy question actually. to answer. We've gravitated entirely towards leap.app. You know, it's funny. This used to come up. What was it? Leap. A cloud, was it?
Yeah, I think it's
there we
cloud.
go.
Yeah.
Yeah, so this is fine. This used to come up like every other week on office hours, and it hasn't come up now probably for 6 months. But yeah, this is the tool we're using. It's open source. It works really well, and makes up for all the rough edges trying to work with an outside IDP and logging in through web flows, etc.
And just the TLDR on that is all the things about configuring AWS config and AWS CLI will do it. It does that for you, like under the hood, as you create things in their UI and set it up once. It's pretty slick.
So, so can I say something?
Yep.
Thank you, guys. Thank you. A lot of information there. I am using Lee app.
Oh, you are? Okay.
I am using Lee app, but still things are not quite, clear to me. I cannot quite replicate the CLI experience that I had with IAM, with SSO. Maybe I can also just add one point, maybe for next time or whatever. So I don't use an external IDP. I just use SSO. So just SSO. And so previously the users and presently also actually the users were managed by IAM. And yeah, I wanna move to SSO. And yes, I'm using Lee app, but as I said, one thing with Lee app or SSO, I mean, it's not that bad, but it's just there are little things that are not as good as before with IAM. That is one thing is every time you log in, it goes through the browser. So you have this switching between the browser and CLI, and also, like, I did not, maybe there is, maybe I have to play around more with the Lee app, but I didn't find an easy solution, for example, to have different accounts connected in different terminal windows, for example. But previously that was very easy with the AWS profiles. So I don't know, probably I'm missing many things. That's why I was asking.
Yeah, for sure you're missing some other things. So I can tell you that we use Leap to manage like all of our customers, and we jump back and forth between customers pretty frequently. And each one of our customers has, tens to hundreds of accounts depending on the size of the customer. And when we're able to sort of manage that all with Leap and some other scripting and things we have around that. But what I can tell you is that if every time you switch an account you're getting a browser pop up, definitely something is not configured properly, because you should only have to get into your browser through AWS SSO once every time when your session expires, basically. So if your session is an hour-long session, you maybe have to do it once an hour. If it's a 10-hour-long session, you should only have to do it once every 10 hours. It's not, so there must be something that's not configured right there.
The other thing that was mentioned was just, you still have to manage your AWS config file to simplify the process. And what we do is, this is the one like rough edge I really don't love about what we do, but we have a shell script that just frankly generates that AWS config file. It could be done in more elegant ways, I'm sure, but the gist of it is, once you have that config file, now you just set an environment variable per terminal window, and that's the role that you're using.
I wrote a bot that generates an AWS config for each of our accounts, and it's been pretty successful. Actually, get users to use it successfully.
That's great.
Yeah, I think. Yeah, and I'll just add to ours. Just remember that the reason we do it through a script is because this is often like what we're doing early on in the process when we're bootstrapping accounts, and it needs to be portable across AWS organizations that don't have anything like running in it. So every time we move to a different customer, we need to be able to like create a new config for that customer. So I'm not sure there's really a much easier way, although we could probably get Slick and read it from the API and then do it
that's
that
what I'm
way.
hoping
But,
we do
you know,
somehow at one point.
Yeah.
But it should be an Atmos subcommand.
Yeah.
All
So,
right, everyone.
anyway,
we are at
there we go.
time. I want to be respectful. I know everyone has got their next meeting to go to. Thank you so much for joining us today on Office Hours. If you haven't yet subscribed to our YouTube channel, head over to youtube.com/cloudposse and subscribe. Your following us helps us out a great deal. If you haven't yet subscribed to our newsletter, all these interesting links and information we come up with on our Office Hours, we syndicate out to our newsletter. Go to newsletter.cloudposse.com to subscribe for that. And if you haven't joined our Slack team, that is where we congregate as a group. We have an Office Hours Slack channel there. There's tons of conversation going on there and in our Terraform channels and so forth. Connect with me on LinkedIn at linkedin.com/in/Osterman. Again, linkedin.com/in/Osterman. And if you're interested in seeing what it's like to work with Cloud Posse, I recommend you check out our quiz. Go to cloudposse.com/quiz, answer a few quick scoping questions, and you'll book a session with me directly at the end of that. So go to cloudposse.com/quiz. Thank you all. Have a great rest of your week and talk to you next week.